Welcome, ladies and gentlemen. We are going to talk about composite functions today. So I'm going to give you some brief overview on kind of what a function is in case we're a little confused on this part of the vocabulary instead of the composite part. So we'll start off with what are functions, what do they do, and kind of how should you be thinking about them. And then we'll talk about what are composite functions and how do we use them or do them in math. Okay, so yeah, our objective today is just go ahead. We're going to make some composite functions and we're going to evaluate them, meaning we're going to plug in. Whoops, that's not how you spell plug. Yes, it is. Plug in. Okay. All right. So let's start by talking about what is a function in general, in case you forgot from your algebra classes or wherever. So a function is just a pattern or relationship that relates to variables. This is like, if I know x, how do I get to y? How do I change from my x variable to my y variable? Normally we have like an equation here. So I take the x variable, multiply it by 2, and then add 1, and then that'll give me y. So it's just telling us how do I get from one thing to another, and it's going to always follow the same pattern or relationship. Okay, so basically a function is an equation that tells us if I know x, how do I get y? Okay. This is in function notation. So instead of having a y here, we use f of x for f of x. The f part, that's the name of our function. And then this part is our input. It's telling us what do I feed the function? What do I give it to get the output? So we're going to put an x into the f function. I have to know what x is, and I put it in there. And then the function does the multiplying by 2 and then adding 1, and then spits out an output. Okay? So you want to kind of think of functions as just a machine or something that you give it something, you give it a number or an expression or a variable, it will do some math to it and then spit something else out. If you want, you can think about it kind of like the Dr. Seuss, I forget the name of it. It's the one where they're putting stars on their bellies and then taking the stars off their bellies and things like that. So you want to think about it like that star belly machine. Here's our function machine x. You put x into it, you feed it on like a little conveyor belt, right? It goes in, it makes some noise, sparks fly off, you know, ah. And then on the other side of our conveyor belt, it spits out our y. Okay? So that's what a function is. You give it something, it does some math, and then it spits out an answer. Okay. So what does it mean to have a composite function? So composite functions happen when there are two or more functions that get used on the same variable. So if we kind of continue our star machine function, right, the thing from Dr. Seuss, if we have a composite function, all that means is we have a conveyor belt, and we're going to put our x on it, and it's going to go through the function machine f. Here's f. And then on the other side of our conveyor belt, it's going to spit out y. Now, instead of just ending there, to make it a composite function, what we do is put a second machine here. Let's say this is our G machine, and now it just takes whatever that output was. It takes this y we have and does another function to it, and it's going to spit out another new output. Maybe it's z this time. So a composite function just means we take one input, feed it through multiple functions, and then get an output. Okay. So a couple things with this. What we're going to be doing today is we're going to learn how to put the variable into a function and evaluate it to get the output. We're also going to learn how do I just make this into one machine and skip this middle step, no more x. What we want to do is condense our machinery so that we have one box, and this is going to do f then it's going to do g. So we're going to still feed it our original input of x, and then on the other side, it's going to turn it into the y, and then it's going to take the y and turn it into a z and skip the middle step and just give us our z output. So what we're going to learn is how to take these two different machines. Sorry, let me change colors. We're going to take this f machine, this g machine, stick them together, and make an fg machine. And that's all a composite function is. Okay, so let's learn how to do that now that we have an understanding of what our goal here is and what we're actually doing. All right, so in this process, we're going to substitute one function into another function to combine them. So I made two example functions. We have our f function and our g function. Let me switch back to red so it's easier to read. We have f and g. F is going to multiply by 3 and add 6, and then g is going to square something and multiply by 4, multiply something by 7, and then do some adding and subtracting. Okay. We want to figure out what is the fg machine. If I stick these two functions together, what's the new function? You could even call it h if you want, or something like that. What is our new function once we stick them together? So here's how we do that. First, we need to know which function happens first and which function happens second, and where to stick those. So the inside function, the g function, is the one that's happening first. In this notation, this doesn't mean multiply. It's an open circle. It means composite function. The one we do first is the second number, or second function name. So what we're going to do is we're going to take the outside function and we're just going to write that down. So our f of g of x is, I'm going to copy the f function, 3, but instead where the x is, I'm going to replace the x with a big open set of parentheses. Okay, so there's my x. It's now this set of parentheses right here. I'm going to bring down this plus 6. Okay. So I write the outside function first. I write down the function, and anywhere there are x's, leave blank parentheses. Now we need to install this or plug this second g function into the f function to make it work. So where these parentheses are, we're going to take our entire g function and we're going to plug it into the parentheses. We're going to substitute it. So 4x squared plus 7x minus 2. Okay. So we've done the substituting. Now this looks awful. This is ugly. It's not wrong math, but it's sloppy, lazy math. We need to simplify this so that it looks nice and readable, and I don't have to think about what is this coefficient actually after I distribute. We'll just do all the math and clean it up as much as we can. So once you do the substitution, then simplify. So do your distributing, do your reducing, do your combining like terms. So we're going to distribute this 3 to all the coefficients inside the parentheses. We're going to get 12x squared plus 21x minus 6. And then we can't forget this minus 6. We're going to need to bring that down. It's part of the function. We can't just get rid of it. So plus 6. Now we need to combine our like terms to make sure it's as cleaned up as possible. So like terms are like x squared plus 3x squared. Because the x squareds match, we just add their coefficients, the 3 and the 1, and then leave the x squareds alone. So if I look here, I have 12x squared. There aren't any other x squareds in this, so there's no like term for this to combine with, so we just bring it down. 12x squared. Same thing with our plus 21x. There's no other x's to combine with, so we just bring it down. And then negative 6 plus 6, negative 6 plus 6 is 0, so these cancel each other out. You could put plus 0 there, but it looks sloppy. I wouldn't. We're trying to simplify and make it nice. So we'll just go ahead and take those off. So this is your f of g of x function. This is your composite function right there. Just so you know how to read this out loud, so that if you're talking to your friends or like a professor or a boss someday, you sound like you know what you're talking about. The way you would say this out loud would be f of g of x. It's where the parentheses are. You say the word of. Okay. So that's how you composite two functions together. Now let's go ahead and talk about evaluating these. We need to do f of g of 2. So they're telling us this x right here. Now we know what x is. It's 2. We're going to plug that in. So we have two options here. If we already know f of g of x, which we do because we just solved for it right here, if you know the finished composite function after you've done all your simplifying, you can just go ahead and plug x equals 2 into this function and simplify, and that'll give you your answer. So that's what we're going to go ahead and do. So f of g of 2 is going to be equal to 12. Where the x is, we're plugging in 2, so times 2 squared. This is the big mistake people make, is they forget the squared. Plus 12 times 2. So 2 squared is 4, times 12 is 48, plus 2 times 12 is 24. And then we add, so that's 2, carry the 1, 6 plus 1 is 7. So that's 72. Okay, there is a second way you could do this problem if you didn't already know your composite function after it's been simplified. The second way that we can do this problem right here is we can plug it in one function at a time. Going back to our analogy, what we just did is we put our 2 into this big simplified machine, okay? Because we already had the machine built. If you haven't gone through all the work to stick these together, you can do it this way. We can plug our 2 into the first function and then get that answer, and then plug it into the second function to get our final answer, and they should still match. So we'll go ahead and try it that way just to make sure. So here, if we look at this, the 2 is inside the g function. So that means we're going to plug the 2 into the g, and then whatever we get from that, we'll plug that answer into f. So here's our g function. I'm going to plug 2 into that. So g of 2 is 4 times 2 squared. Let me just double check the function. Plus 7 times 2 minus 2, I believe. Yep, minus 2. So we'll simplify this. 2 squared is 4. 4 times 4 is 16. 2 times 7 is 14 minus 2. So this is 28. What we have right now is that middle step. We still need to feed it through our second machine. We've done the middle part. Now we're going to take that answer and plug it into our f function. So we're going to take 28 and we're going to plug it into this f function right here. So 3x plus 6. So this is going to be f of 28 equals 3 times 28 plus 6. Oh no, I think I've done something wrong. Allow me to pause this real quick. All right, sorry, I found my error. Right here, this should be at 21. Sorry. So that just changes this to a 42, which means this is 90. Sorry. All right. So again, we plug our 28 in. 28 times 3 is 84 plus 6. We get our 90 again. Okay. So there we go. That's how you can composite functions and then how you can plug them in. I'm going to do 2 more quick examples really fast just so that we have, or rather you have, something else to look at and compare on. And then after that, you're going to go ahead and go on to your online homework, and you're going to try that. If you need more help, you can either try and watch the video again, or you can go to my WebEx and ask me for help. All right, here's our second example. This is the same two functions. The only difference here is our order of our functions has switched. So we're going to do g of f of x now, and then we're going to plug in 3 instead of 2. If you switch the order of the functions, if you do f of g of x, and then you compare that to g of f of x, these things are not always equal. Sometimes they can be, but sometimes they're not. There's not really a pattern. Certain functions will work either way, or some of them will undo each other, and there's special names for that. So we'll go over that later. But for right now, just don't assume that they're going to be the same. If you change the order of the functions, it might change your end result. So to find our composite g of f of x, we're going to start by writing out our outermost function, and where the x's are, we're going to replace those with blank parentheses. So g of f of x equals, we're going to write g, so 4, where the x is, I'm going to put parentheses, squared, because the 2 is not part of the variable, it's a math operation, right? We have times 4 and squared, so all the math operations stay. Bring down our plus 7, where the x is, put parentheses again, and bring down our minus 2. Now, we're going to take the inside function, and we're going to plug that into the function we just wrote out. So we're going to take our 3x plus 6 and put it in both of our parentheses. Now we have to clean this up, and this is a little bit of work, but that's all right. We're not scared of a little bit of work. So right here, doing order of operation, we do the squared before the coefficient. So I need to square 3x plus 6. The way you would do that by hand, in case we've forgotten, is you're going to take 3x plus 6, and then you're going to multiply it to 3x plus 6, and you would want to FOIL or distribute, or however your teacher says it. I'll use both of them. So what that means is you're going to take 3x, you're going to multiply it to 3x, you're going to take 3x, multiply it to 6. Then you're going to take 6, multiply it to 3x, take 6, multiply it to 6, and then add all your like terms. I'm going to go ahead and use a shortcut because there kind of is one. So this is 4 times 9x squared plus 36x plus 36. The shortcut is I did it on a piece of paper that you can't see. Okay, so I FOILed that out. Now I need to bring this stuff down. We're going to distribute our 7 and bring down our minus 2. So let me move this. There we go. All right, so distributing the 7. 7 times 3 is 21x. 7 times 6 is 48 minus 2. Notice we still have these two parentheses right here. Those are right there. And these parentheses disappeared. That's because I did the distributing here, but I haven't distributed this 4 yet. So let's go ahead and do that. So we're going to distribute our 4. So this is 36x squared plus 144x plus 144. Now we just copy down these terms so we don't forget them. Plus 21x plus 48 minus 2. And now our last step is just to combine our like terms. So the x squared doesn't have any like terms. I'm going to bring that down. 36x squared plus, here we have 144x and 21x. Those are like terms, so we add their coefficients together because they're both positive. So 144 plus 21 is 165x. And then 144, 48, and negative 2 are all like terms because they're just numbers without variables. So we can go ahead and subtract. This is 46. And then 46 plus the 144 from over there is going to be 190. So this is our function. Okay. This is g of f of x. All right. Now the last thing we want to do is plug in 3 to our composite function. Because I've gone through all this work, it's 2 lines. To get our final composite function, I'm going to just go ahead and plug in x equals 3 here. And then that'll give me my answer. So g of f of 3 equals 36. Whoops. I apologize. That should be a 9. 9. Whoops. No, it shouldn't. I'm sorry. Should be a 3. 3 squared plus 165 times 3 plus 190. And once you have added these all together and simplified, you should end up with 1009. All right, so there's composite functions. If you guys have any questions or need help, email me, hop in the WebEx, watch the video again, watch a different video. Go look on YouTube and see if someone teaches better than me. Okay, I will see you guys in the next video. Have a great day.